Okay, hello everyone. Welcome to Mirantis Labs Tech Talks, where we dive into cloud native topics, use cases, tutorials, and many more to educate you all. I'm Avinash Desiredi, Senior Solutions Architect and Developer Advocate here at Mirantis. Joining me here today, Rick Smalling, Developer Advocate at Sneak, to talk about why developers should care about container security. I and Eric worked together back in Docker. And Eric, thank you so much for joining me here today. And can you please give us a quick intro about yourself?
Sure. Are my slides presenting? I can't see it now.
Yes.
Okay, cool. Hi, everybody. I'm Eric Smalling, Senior Developer Advocate at Sneak. And as Avinash said, he and I worked together at Docker on the professional services team for a while, um, and here in the United States. So my background is software developer mainly. If I can get my screen share to pay attention to me. There we go. I've been working in software development for, depending on how you look at it, up to almost 30 years, and most of it here in the North Texas area in the travel industry. The last decade or so of my career has been mainly around consulting in the cloud native or in the DevOps space, if you want to call it that, doing CI/CD, doing tooling, and it was through that where I learned about Docker. Started using it way back in the pre 1.0 days. Um, the I think it was as I have it on here. I think it was .6 was the version we were using, and we used it a lot for um, running Southwest.com. Honestly, is where I worked, and we ran the app, and we ran 700 functional tests every 20 minutes on that thing. So we used it for Selenium grids and doing all sorts of stuff. So I have been a Jenkins ambassador. I am a Docker captain now, and I have CKS and all the other CK certifications. So if you care to follow me, I'm Eric Smalling on most of the socials and things like that. We
Yep. Awesome.
You want me to go ahead and get into it, or we want to? Do you have anything else you want to discuss first?
There is one housekeeping item. So the Q&A panel is open. Please do post any questions that you might have during the session, and we will get through them uh, throughout the session. So with that, Eric, we can get started. Thank you.
Cool. So, as I said, I'm a developer background, and I created this discussion around what it is that, as developers, we need to care about around container security, because it's not something that a lot of the developers, think about when when they're coming to it. Is what is the challenge? And we're going to start this out with talking. And by the way, I'm wounded today, so if my typing is really bad when I get to the demo, I apologize. I have no right thumb today. This is day 2 with this thing on, so I'm going to start with talking a bit about what is DevOps and how does security work with it, and what is DevSecOps, which is a term you may have heard. And then we're going to get into those container challenges. What is it that, from a security point of view, challenges us around containers? Then I'm going to do this demo, hopefully. Well, and finally, conclusions. And as Avinash said, if you've got questions, put them in the Q&A. I will try to either address them as they come in if they're pertinent to what I'm discussing, or we'll hit them at the end of a section, but we'll try to get to all of them as we go. So we all know, and we've all heard of DevOps. It's a term that's been around for a decade plus. And it's all about development and operations working together and the tooling around that and whatnot. And when you think DevOps, usually the first thing that comes to mind are software delivery lifecycle and pipelines and how to implement them and how to operate them. When it comes to security on top of this, historically, these security has been applied to our pipelines in kind of on the right-hand side or the ends of the pipeline. And I represent that with our little Sneak logo patch on these, that's his name, Patch the dog, on this pipeline. Is these are the historical places that you see it applied. So obviously production. We've always had security concerns at production. You've got firewalls, you've got tripwires, you've got intrusion detection, all the things that commonly are done for any application, whether it's containerized or not. But as security started to evolve and these pipelines started to become codified in tooling and in process, we started seeing it applied as stages in your CD pipeline. And often this was a late stage, though. It was something that either the tool took forever to run, or it was licensing reasons made it only run on like a specific set of hardware, or it was a manual gate often, where a security team, the pipeline would stop at a certain point, they would do the audit of the release before it goes out. But it's usually after functional testing and performance testing and things like that, because it took so long that you didn't want to block the pipeline earlier to go through those audits if it wasn't a release candidate type of a thing. As things have matured, we've seen security start to get applied farther left or earlier in the pipeline. And we see things like at the bottom there, the registry. Your containers images get pushed to a registry, and oftentimes that registry has some kind of tooling in it that will look at the image and look for any vulnerabilities in it. And some amount of time after your systems have pushed an image there, you'll get a report back, which is kind of like a spreadsheet of CVEs or something that might exist. Some tooling actually has been applied at the repository level, and this is where a build is finished and is pushed in. The code is pushed into the repository, and some kind of CI process may run it. And again, usually this happens at some point in the build, and it breaks it like a test would break it. Speaking of tests, you could apply it as a pull request, a pre-merge type of a thing, where as the code review is happening, automated code review could be happening around build quality or code quality and things like that, while security can be applied there as well. The holy grail, though, is to get security testing as far left in this pipeline as possible. I mean, the whole point of continuous integration has been fast feedback. You want to give a developer information about a problem as fast as possible while they're still, have the context of what they changed in mind. And the sooner you know about something, the sooner you can fix it. So if you could get security all the way to the left as early as pre-commit, like happening on your desktop, in your IDE, that's kind of the goal of, this is where Snyk lives, and a lot of tools like ours are starting to try to get into. And this is not a Snyk pitch, I just using our logos because I like patch. This is what DevSecOps really encompasses, is including security to our little DevOps party, right? So security doesn't apply in a late stage because they don't want, because they're not good at it or because they don't want to. Oftentimes they haven't had the tooling available to allow them to be part of this iterative process. So that all being said, what are these security challenges from a container point of view that we face as developers? First of all, we've increased our scope of responsibility. As a developer, I know I need to write clean code. I need to not be, taking unvalidated input and throwing it right at a database, all that kind of good stuff. But when it comes to containers, there's a whole new scope of things around operating system level issues. You've got packages that are coming in through, APK or APT or run, all these operating system level packages and what's coming along for the ride with those. My base image that I've selected, what is in that base image? What distribution is it based on? What is going on there? Is there middleware? Am I using an image that has some kind of middleware? And what version of that? And all of those kind of questions come in. File permissions, user IDs, all that kind of stuff, which commonly we don't have as much expertise in. Now, if you're a nerd like me and you've built Linux machines on your own, and you may know a bit about this, but this has been kind of the arena of the operations and security teams and network teams and other teams that have worked with us in the past to provide us secure systems to use. And they usually would tell us, you're going to run as this user, or you're going to use these file permissions, or you're going to use this middleware cluster to deploy your jar files to, or WAR files or whatever. And we just haven't, as a whole, we haven't had to deal with this as much. And on top of all this, of course, the whole reason we've gone to continuous delivery in DevOps practice is velocity. The idea of from business ideation to production, trying to make that happen as fast as possible. Any kind of security process or tooling we're adding needs to not slow that velocity down, because if it does, business is not going to be happy with us, and things might get skipped. So when I say applications and developers, what does our app or service, if you're doing microservices, contain? Well, obviously the source code. So here we have a Flask app, right? A Python code. We all know that. Third-party dependencies, things that you're pulling in. In this case, again, in Python, you might be using PyPy or PyPI. I can't remember PyPy. I can't remember how they say that. I'm not a Python developer. If you're a Java developer, you might be using Maven dependencies, right? We understand that what we're pulling in needs to also be secure. So I can't be just pulling random libraries off the internet somewhere. It needs to be something that we vetted and we made sure is good. We also now have Docker files, though, and this is what I was talking about. We have operating system level concerns. If you look at this little snippet example, we've got a Python 3 base image. That's what that from line means, right? Well, what build of Python 3? What distribution is that based on? All sorts of questions start to come up. What is this stressng apt package that we're installing, and what comes along for the ride with it? Other dependencies it has, and so forth. Things like that start to really get outside of our area of expertise. Then, of course, layer on top of that, you've got infrastructure as code. So you might have Terraform to bring up your application's infrastructure or configure its network connections or whatever. And then the granddaddy of all of it, obviously, Kubernetes. That also falls under infrastructure as code in that it's defining how your containers and their pods are going to run, how they can connect to each other, what's the services around them, all of that, the Kubernetes API, which changes 3 times a year and all that. Just getting your app up and running is enough to make a developer hyperventilate. Keeping it secure is a whole another ball of wax. So I almost hesitate to bring this slide up whenever I do this because I don't want to throw Capital One under the bus in any way. They're local here in Dallas Fort Worth. A lot of the folks I know they're great and they're wonderful open source contributors. But I do bring up this example as one that we have to think about in that they had an attack in 2019 that was the perfect storm, if you will. I've heard numbers of over $100 million lost that the company took because there was, gosh, it's been a while since I've looked at this, but if you look at that link at the bottom, you can go read all about it. But there was an application vulnerability paired with a misconfiguration of a web application firewall paired with other things. And it really underscores the complexity of the distributed applications we are dealing with. And often the things that are the parts of these services aren't even ours anymore. They're cloud services, or they're other parts of your company that you may never even knew existed are all tied in. And you look at some of the graphs I saw an Uber graph yesterday that was amazing. The Death Star photo of how many thousands of services are all interacting. And no one person understands that, this change in configuration, how it domino effect could to hit other things. So making sure that you are doing your part to be secure and scanning your code, your IAC, and all that kind of stuff is very important. So enough slides. Let's take a look at a demo. So I am going to see if I can get my correct screen to come up here. Again, work with me with my broken hand. I don't have my other slide up. So let's set the scene here. We have an application that is an old Java application that, I'll just show you the file. It'll probably be the easiest thing. We Dockerized. We put into Kubernetes years ago, and we kind of did a lift and shift because we just want to take advantage of the standardization of this deployment model, right? And it's a simple Maven app. It's a Java JEE application that we build with Maven. This is a multi-stage Dockerfile if you've not seen one before. So we've got 2 from lines. The first stage is our build. We're building the application, basically just doing a Maven build, creating the WAR file in this case. And the second stage, we're basing on Tomcat as our final image that we're going to produce. And we're just we're making a directory, copying our web XML that we need in there, and then bits from that build come in. So the jar files and WAR files that we need to run the app. And we're applying a label at the end. That's just bogus for example purposes. But that is running. I keep losing my browser tab. If I refresh my page, there we go. So we got there's just the front page because I didn't put a context on it. I'm just running this locally on Docker desktop. I'm not doing anything fancy here. And there's the app. Now, the app I'm actually not really concerned about. What I'm concerned here about is Tomcat. So let me put on my black hacker hat. And as a bad actor, if I can get the right tab open here, I probably am investigating, often looking for application vulnerabilities in commonly used middleware. And Tomcat, being a web app JEE server, has this page that is basically, I can get all the way to the top of it, good grief, Tomcat 8 vulnerabilities that they've fixed through the years. And you can see that there is a lot of changes that have come in over the years. And while looking at this, see if I can get it to go back to the, I'll find it. I happened to stumble while I'm drinking my coffee one day. Oh, there's a remote code execution vulnerability that was fixed in Apache Tomcat 8.5.23. That tells me that anyone who's not been upgraded past that might be vulnerable. So if I look at the CVE for this, I'm just going to open another tab. CVE being the common vulnerability information. Here's the Sneak vulnerability database. This is just like MITRE's. Our security teams add a little extra metadata to make it look pretty, but this is basically what you'd see on MITRE. It tells me a bit about the vulnerability, and I could go in and research it. I could try to figure out how do I break this thing, but you'll notice there's a couple of exploit DB links here, and one of these, if I click the right one, yes. So exploit DB is a place where you can see examples, and this is an example of exploiting this vulnerability. And this is just a Python. This is actually there's two of them here. I'm going to show the other one. This is the one I'm going to use. Here we go. So this is a Python proof of concept for this vulnerability. And without digging too much into it, because again, I'm a middling Python developer, I tinker, but basically it has two functions in it. One of them to check to see if a given endpoint is vulnerable, and the other one to implement a hack on it. Now I've taken this, copied it down, and I have it in tab aliased here. And I have the first half of that behind an alias called check, and I've got it canned to hit my version. Imagine this was on a loop, just pinging the internet, looking for open ports and seeing if any of them respond correctly to it. This one has hit my local Docker desktop on port 8080, and it literally called in and made sure, yes, I have found a vulnerable, what I think is a vulnerable endpoint, and it has put in this POC that if I go back to my browser and we change from to-do list to poc.jsp, I promise you that was not there a moment ago. It's a simple JSP that just spits out some A's, which itself is graffiti at best. However, I just injected the JSP into my Tomcat, somebody else's Tomcat container. That's horrible. Now, if we take a look at, now we found one. I come home, I get my list, kind of like the old war games when we get war dialed, right? Found the Whopper. Well, we found something. So I'm going to run the other half of this, which I aliased as pwn. And so we come back over to here. If I change poc.jsp to pwn, now I got a little form here. And if I go ahead and let's do a host name. That just ran the host name command inside the environment that Tomcat, that application is in, that server. Now let's see, let's do an env. I'll shrink my font a little bit here. By looking at this, I can see all sorts of good information. This is the environmental variables that Tomcat server is running under, and I can see a couple of interesting things about. There's my Catalina home, so that's the path that I'm running at. All sorts of other things. I see something here that says Docker Java home. So, I'm probably in a container. That's good to know. Let's see if... Oh, and I'm root. That's handy. Now, as a developer, you may or may not know that most default base images, most official open source images out on Docker Hub are any image you make from scratch it defaults to root. Most open source images leave it that way and then either give you another user you could use, or you could make a user and run as a non-root user. You should, and we'll talk about that in a minute. But why does it matter if I'm in a container? Well, let's do this. Let's see if I can do this. Touch etc foo. And now we'll do ls-ltr etc. Scroll to the bottom of this, since it's sorted by date. I just created a file in the etc folder inside this containers-based file system. So at this point, I have control of things. So I wonder if I could do this. Now, apt-get update only returns a little bit, and then it kind of hangs, or it doesn't hang it. It starts doing standard error. So standard out, output that. That tells me, looks like I have access to somebody's apt repositories. That's kind of cool. Let's install, and I think I have to give that a Y. Oops. But, I mean, I'm not going to belabor this, but I can go in. Now, this also doesn't output anything with standard error. But while that's running in the background, see if it's there. Yeah. Well, it would work if I'm kind of going off script now. But I can install things because I have apt-get available to me. Let's see if I also have this. Let's see. HTTPS, google.com. I got a 301. That's actually good. That tells me that I actually talked to something that spit back a redirect. So I have curl. I have internet access. I have app repositories. I basically, at this point, honestly, my whatever script that's doing all this kind of things is probably saying, okay, let's put some kind of crypto miner on this and just use whatever CPU we can get. Because if they haven't restricted any of these things, they probably also haven't put any limits on memory or CPU use or anything like that. So we have free compute cycles we could exercise, right? So all that being said, in a real world, hopefully your production intrusion detection or something is detecting this errant behavior and letting you know so that you can lock it down, react, whatever. But wouldn't it be better to, as I said, shift that left and find out earlier? That's where the container scanners come in. And I'm going to kill out of this. This is the tab that was running the app. I'm going to kill the app. And now let's imagine back in developer's hat, I'm a developer that happens to be working on this application. Come on, Java goof stuff. There we go. And just to make sure I clear everything out. And I am right here where my Dockerfile is, where my app is, and all that. I'm going to run our tool. Now, again, you could use Trivy, you could use Gripe. There's a lot of tools that can help you find vulnerabilities. But I'm going to show you container test, and I happen to know that this is Java goof orig is the name of the container. I'm going to feed our tool a little bit of extra info by giving it the Dockerfile, so it has some metadata to go with the image. What's happening now, and what most container scanning tools will do, is they will go through and look at through the layers of the image, look for what packages are installed, among other things, and they'll start looking at a database. Our database is online, so it's going to start. You'll see it's querying database. So it's pinging the Snyk vulnerability DB right now, looking to see what it finds, and you'll get a list. And each tool has a different output. Ours comes out in this summary form, or you can change the format to JSON if you want to ingest it for other uses. But one thing our tool does that I do like is that at the bottom here you can see that we've detected that this is Tomcat 8521 base image. Now, if any of you out there who are like me are a Java developer, you know that's hella old, and it's just a really old version. I use it for this demonstration because there are plenty of operations teams out there who will deploy something and then take the "if it ain't broke, don't fix it" point of view. Especially for an app that maybe is in legacy, keep it alive kind of. We don't want to touch it. We just want it to run and do its thing. Well, in this case, doing that has brought 735 vulnerabilities in just because we're on Tomcat 8521. 71 of them are labeled as critical. 193 high. It's funny, every time I run this number changes because the vulnerability database constantly gets updated. What's cool here though is the tool will give you some recommendations, and it'll say, hey, if you were to just upgrade to a newer 8.5 family of Tomcat, you would drop your vulnerability counts, and you drop to 5 critical, 9 high. If you're willing to go to Tomcat 10, no better. So that's not even worth talking about. But if you're really want to get crazy, you could go to one of these alternative builds, which are using the Corretto Amazon build of the JVM, and get to zero. Zero is actually rare. You often, most base images have some vulnerabilities because there's a lot of things that are either very hard to, that the open source community just hasn't fixed because they haven't raised up, they're not a high enough priority. But you could. So even if I'm a junior developer, I don't know anything about containers. I don't know much about Tomcat really. I just know my Java app. I can at least now take this kind of information, go to my lead, go to my security team, and have a educated discussion about here's the recommendations that are being made. What do you think we should do? And as an architect, I might look at this and say, well, we're not ready to go to Tomcat 10 because we know we have API problems with that, and I'm not ready to drink the Amazon Kool-Aid and go to Corretto yet. But we should at least get on the newer version of Tomcat to fix these. So let's upgrade to the latest build of Tomcat and take advantage of that at least. So it's telling me to go to 8579. So I'm going to make that change to my Dockerfile. And let's kick off another compose with build. Now I'm using compose just because it's simple. I've done this demo with Kubernetes. It doesn't matter where you're running it. This is pulling in that new version of Tomcat. It's building my application, which gives me a second to take a sip of coffee. And there we go. It looks like the app is up and running. So if we come back to my browser, let's go back up to the top here and see. Okay, that's interesting. I got a 404, but let's see if the app is running. It is. And I could go through the app and I would regression test it, I'd do whatever. But more importantly, let's go back over here and run our exploit DB check. Not vulnerable. Just by moving to the newer base image, which has the newer version of Tomcat, without changing my code at all, I have eliminated this RCE, this remote code execution vulnerability. And there are many kinds of vulnerability. I'm just using that one because it's the most, the scariest one. The one thing that was interesting is you saw the 404 here. In between 21 and this version of Tomcat, the Apache folks realized, you know what, we probably shouldn't be shipping the manager, which is that pretty Tomcat dashboardy kind of thing, with a production class image. This isn't something that people need in production. If they need it, they can install it on top, which is part of the reason why this vulnerability got fixed, because I believe a piece of that vulnerability was related to that, because you're posting through what was that context. Anyway, so that all being said, what we saw is an example of shift left, right? As a developer, I have a tool that is fast enough and gives me proactive enough information that I'm able to head things off before they ever get to production. And that's the goal. You're never going to catch everything, but you should catch as much as you can. And having tools that give you that kind of information and using them is important. So I see we got a question that came in that says, right now, most of our applications have been migrated to Spring Boot. Has the Spring Security plus other resolve the middle? So same kind of a thing. So Spring Boot, this is more of an application dependency thing, because I don't think there are any Spring Boot base images. Correct me if I'm wrong. If there are, hopefully our tool and other tools would let you know about them. But I know for our product suite, again, this isn't supposed to be a sneak commercial or anything. Our Java dependency scanners would catch that for you, and they would tell you. You can go look at our blogs. We talked about the Spring Boot one when it came out. They would have caught the RCE in Spring and told you, hey, you need to upgrade your dependencies on Spring and rebuild. So yes, kind of tangential to containers, but I'll address that a little bit more here in the next section, I think, too. So the standard DevOps infinite loop, I put this in here just to kind of underscore, we shouldn't really think of our pipelines as left to right. They really are an infinite loop, because vulnerabilities can be found even though you haven't changed your Dockerfile. You've been sitting on this old version of Tomcat thinking you're safe, but a vulnerability was found in it. Think of Spring. Think of Log4Shell. These were things that were found in libraries. I mean, Log4j, that change had got put in 2013, I think. And we didn't know about it until the end of last year. So, and this is definitely not a Java-centric thing. I'm just a Java developer, so it's fresh in my mind. These things happen in Node.js, in Node npm dependencies, in Python, all sorts of places. But like I said earlier, you're not going to catch everything because there are 0 days. There are things like log, again, to use log4j or Spring, that are going to come up that you're going to have to react to. But how could you make your applications be resistant to those kinds of attacks, or reduce the blast radius should somebody exploit one of those kinds of vulnerabilities? And that is to practice defense in depth. And there's 3 areas I'll touch on here: the images, your runtime, and then specifically some things around Kubernetes you can do. First of all, you want to minimize your footprint. The Dockerfile I showed you was using the official Tomcat image, even the newer version, or when we upgraded it, but it's using the general version, which is based on a Debian-based image that has everything that you might need as a developer. There are smaller images. There are slim images. There are alpine images, which is a different thing we'll talk about. And then there are distroless, which are images that have just what is the bare minimum needed to run a JVM or something like that. By minimizing the footprint, you're not just saving on transmission speeds and of the images and whatnot, but you're keeping tools that the hacker could use out of the image. So when I did the hack, curl was there. My app doesn't need curl, so it shouldn't be in there. The slim version of that image would not have had curl in there. All sorts of other tools at their disposal. When I was talking to some pen testers a while ago, and one of the things that's big on their slate of tools or tool belt is to live off the land. You want to, if you get into an environment, you want to use tools that are already there, because as soon as you install something new, that could trip intrusion detection or network connections that they weren't, that are unexpected. So if the tool's already there for you to use, you're gonna, it's you can exploit, you can use it. And you need to understand how layers work in images. So if you're new to images and can Docker and everything, understand that it's kind of like a Git repository, and that every time you add something in that Docker file, you are layering on top of the other things. And if you try to remove, like if I did a run rm curl, that doesn't really get rid of curl. It just hides it from the final image. And if somebody errantly bind mounted the home the var host mount into my container, and I'm able to get into, like say a directory traversal exploit, I could get into and find things in var run docker image. The layers are all there, and I can find things that way. I've seen some capture the flag games where people use that they'll get, oh, I can go and use these tools that normally wouldn't be available to you. So if they're doing it, bad actors are doing it as well. Build strategies. So you saw me using a multi-stage build. That's a great tool for minimizing image size, because that final image you can base on something small, and the prior stages could be based on larger images that have the tools you need to do your builds. This is very common in the Go world. So if you're doing a Go application, often you'll have stages that will build the binary in a statically bound executable, and then the last stage is often Scratch, which is the empty container, and you just copy that down, and now your container is as minimal, as slim as you can get it. As long as your application is solid and you've scanned your code, you're pretty safe at that point. But there are also other things. You want to make sure your builds are repeatable. So using tags that have at least the semver or calver that's specific to the build you want is important. So I could use Tomcat 8, but or like the example earlier in that snippet on the code on this page, Python 3. That doesn't tell me. Every build I do could be a different one. Now that's going to get me the latest usually. That's nice. But in most business situations, you want to know what you're building from the source code. You could get as specific as including your SHA hash of an image. So every image has a unique SHA hash, and if somebody mutates a tag, that if you're using the SHA hash, that has to change, because it's this checksum of the manifest. That's a little more brittle. Some shops don't like to go that far, but at least be using specific semvers. And there are other tools you can use to build images. There's things like Jib and Co. There's build packs and other things that abstract away some of the complexities of how to make a Dockerfile or how to make an image. Take a look at all those kinds of things. And then finally, secure supply chain. There are entire conferences now dedicated to this, so I can't cover that here. But the high 10,000 foot level is know where your images are coming from, and images that you're going to deploy somewhere should always be coming from an auditable place like a CI server or some kind of build that Eric makes on my laptop should never get deployed anywhere important, because you have no idea what I was doing or what other malware was crawling around on my laptop when I built that thing. So always know where your images come from. Images you're basing on should be in most enterprise environments. You probably have a managed image registry that you are supposed to be using for all of your content, just like you probably have a managed artifact registry for your Java dependencies, your NPM dependencies. Same thing for images. Have images coming from a verified, vetted repository that you know is safe or probably being mandated to you by your company. When it comes to the runtime side of it, you saw that I was running as root in that container, which is very common. And even though you're contained, you still have elevated privileges. Most business applications do not need to run as root in their container. There are some exceptions to that if you're dealing with some lower level things, but generally you don't need to run as root. There's been some movement finally in the user namespace side of the container runtime engines, but that's still pretty raw. So if you can just change the default user to something else, and that will eliminate the ability to do apt-get installs. It'll eliminate the ability to get into parts of the file system you're not supposed to be getting into should somebody get out of your application. To do that, you can add a user line to your Dockerfile that'll change the default, but most people will just, in their Kubernetes manifest, set the user specifically. When I get to the Kubernetes part, we'll talk about that. Privileged containers, you don't need. Don't run privileged ever. Okay, if you're developing a Kubernetes monitoring tool, you might need privileged. If you're installing Falco, okay, that might need privilege because of what it does. But for business applications, I mean, I was talking with Jerome Peterzoni, one of the original authors of Docker, and the guy who wrote privileged, and he originally he told me he thought about calling that it says in the Docker command line saying -- privilege -- insecure, because what it does is it basically gives you access to the host devices on you're God on the box, honestly. So don't run it that way, because for example, if that example I said earlier, if you bind mount var into a container and you're privileged, I can do whatever I want in there. If you even if you don't, I can mount, if I'm privileged, I can mount things into it. It's just bad. Linux capabilities are these extra system calls that your process can make that are limited by the Docker runtime. They're not in Kubernetes though. So if you can drop capabilities, you should, because you don't need a lot of things. Like, for instance, ping has a special capability in order to create ICMP packets on the network. And my brain is gone right now. I can't remember this netcap something. You don't need that probably in your application if you're not manipulating network stacks. If you're not writing a CNI, you probably don't need that. A lot of time people will deny all. They'll just drop all capabilities and run that way. And a lot of business apps will work that way. There's a bunch of blogs out there you can just search on figuring out what your app needs using strace or other tools like that to figure out if you do need capabilities, but you probably don't for business apps. The root file system, I was able to touch and create a file in Etsy. Well, if you run as a read-only root file system, what that does is it tells the container engine, don't put that read-write layer on top of the image. The image itself is effectively read-only. Docker, Cryo, whatever, they add a read-write layer on top of that by default where all mutation happens, and it uses copy on write to do the work. If you say read-only, whether at Docker -- read only or in Kubernetes through the security context, it just doesn't put that read-write layer in there, and you effectively have a read-only file system. Now, this is not true of mounted volumes. This is just the base file system, but that keeps me from editing Etsy. Keeps me from editing your app. keeps me from clearing out logs, maybe if you're dumping any, telemetry to the base file system. Again, it doesn't affect the mounted volume, so you should pay attention to the permissions there. But it makes your container immutable, basically. And immutability is good anyway, good at design practice for microservices because it makes it easier for the orchestrator to move it around. So look into that. You might have to tweak some things in your app to make it work in a read-only file system, but it's probably worth doing. And then, again, deploy from known sources. That's a repeat of what I said before. Finally, in Kubernetes, you have some tools at your disposal that if you're not using, you should look at using. Secrets. Don't put credentials in your image, please. That's as bad as putting them into your Git repository, honestly. Secrets are key value pairs that are obfuscated and can be encrypted. And make sure your cluster ops are encrypting them on disk. That's not default if you're doing DIY clusters. If you're using a cloud-based or some kind of managed cluster, it probably is set up to encrypt them. But it allows you to keep these secrets hidden. Make sure you're using RBAC if you do use secrets, because secrets without RBAC really aren't that much better than config maps, honestly. But it's the place Kubernetes gives you to use to put credentials. If you already have investments in Vault or CyberArk or other tools like that, and your applications are using those, keep using them. They're great tools. There's no reason not to use those. You can use those often as backing for your Kubernetes secrets too. If your cluster ops may have set that up as well. I mentioned RBAC, role-based access control. Use it. Learn it, live it, love it. It's just kind of self-explanatory. You want to limit, silo your stuff, keep it secure. And security context. This is the API Kubernetes gives us on top of pods and containers to limit runtime things. I mentioned a lot of the things I mentioned on the prior slide are implemented through Kubernetes security context, the read-only file system, what user to run as. And one bit there is when you, if security context, if you say don't let these containers run as root, what the kubelet's going to do is it's going to look at the image before it starts the container, and if it determines that the UID is 0, it will block it. But it'll also block it if it can't figure out what the UID is. So if you do use the user command in your Dockerfile, use the numeric UID, because if you just say user Eric or user Tomcat, it has no idea if that's UID 0 or not because the container's not running yet. So best practice, if you're using the Dockerfile version of this, use the numeric, or just make sure you're specifying an explicit user in your Kubernetes manifests. Network policies, a lot of developers shy away from network policy because historically network firewalls are another team and it's a complicated thing and I don't want to have to understand bidirectional this and whatever. It's worth your time to learn your network policy for whatever CNI provider you're using. General network policy across almost any CNI plugin it's a set of rules for saying how can pods or how may or may not pods talk to each other. I'm a big fan of the deny all, zero trust kind of a pattern where you basically say nobody can talk to anybody in the namespace I'm deploying this into, except for this allow list. I want my front end application to talk to my back end application, and it uses tags for that, right? These tags can talk to these tags. Sorry, I just hit my mic. Can talk to these tags on this port, and specifically that's it, and it'll block everything else. Now there's some complexities around that, if your company has APM monitoring tools and other things, so you have to work that out where you work, but it really nails things down. And what was obvious in my demonstration a second ago is that there was no network policy keeping me out from the internet or keeping me from somebody else's app repositories. Log4j, to bring that one up again. The way that worked was you injected a JNDI lookup to an LDAP server that was somewhere that you controlled, and that was actually a bogus LDAP server. And it's deeper than that, but that's kind of the gist of the entry to it. If you had network policy keeping people from connecting randomly to things, that stops the exploit from really progressing at that point. And then finally, all the things I'm mentioning here, you need to enforce them. OPA, Gatekeeper, Kyverno, these are admission controller projects that allow you to write policy as code, and enforce the fact that you don't want people running as root or things like that. There's also pod security policy, barely, I think today, that goes away. They actually have removed it in 125, and today is the release date for 125, I do believe. However, most people are not on 125. So pod security policy still exists in the wild. You may still be using it. Be ready, and you're going to need to get rid of it soon and move to something else, whether it be pod security admission controller or one of these tools. But if you're using PSP, make sure you're keeping it up to date and you understand how it works. Finally, and I've been talking a lot here. My key points here, it all comes back to a fast feedback loop. Whatever you're doing, you want to be able to make sure you're letting engineers know as fast as possible if they have a misconfiguration, whether it's through our tools or somebody else's tool, if they have a vulnerability that's coming in through a dependency or a base image or whatever, or if they have Kubernetes manifests that have bad practice in them. There's scanners for that as well. Things like that. Tell them as fast as possible. And the fastest, in my opinion, is part of your build and a plugin in your IDE, things like that. Choose tools that allow your developers to be productive, that give them information that they can use to proactively attack the problem, rather than just spitting a big spreadsheet of here's a bunch of problems, have fun. That's not as helpful. And then finally, practice these defense in-depth things these topics that will protect you for the things that do get through those first two. So with all that, this is a bunch of links. I haven't looked at this page. I think these are all up to date. I will make sure that these slides are available in PDF form. If you follow me at Eric Smalling, I'll put them there. Avinash, I'll give them to you to disseminate as you want. With that, I don't see any other questions in the thing. If anyone has a question, pop it up there. I'd be happy to answer. Avinash, anything from you?
Yep, definitely. Thank you, Eric. This is very detailed and very helpful. And just a quick note to the audience is you will be receiving a follow-up email with the recording link and then the link to the slides as well. And I'm just pasting few links in the chat. Where you can just check out the upcoming events. Events next week, we have a speaker who is going to talk about service mesh and then how to get started with it, how to choose a right service mesh for your application needs. So please do join us next Tuesday, same time 10 a.m. CST to learn more about it. And I did paste a link to our Tech Talks archive, where you can check out all the previous session recordings. Even the current session recording will be posted in there. And I have Eric's Twitter ID in there. So please connect with him. And the security tool that we used for scanning is Snyk. So I have link in there. So please do check out those links.
One other note, if you're running Docker, their command line, Docker scan has our scanner built into it, so you don't even have to install a tool. If you just want to play with it, you can do Docker scan image, and it'll give you the same kind of output you saw in mine. Is there a solution? I've got a question. Sabri asks, is there any solution to scan Docker container in runtime? Very interesting. So my company's solutions are all very focused on developers, right? So the runtime, there are other tools that do that, but scanning a container at runtime is an interesting quandary. For instance, we have a piece of our paid tool, which I don't ever deal with. I don't deal with the paid side of the house, that will look at a container that's deployed, and it will alert you to an image that has vulnerabilities based on the image. But the problem with runtime scanning, or the hard thing about runtime scanning, is that's good to know as long as it doesn't impact your performance of your application. But it's going to tell you at the point that that image started if it was vulnerable or not. If somebody changes the image, if somebody attacks it and makes a change and does something, that's a different thing than scanning. That's more of an enforcement kind of a thing. Now, you could put an admission controller that would stop any image that comes in that hasn't been scanned yet, and we have examples of that, and Trivi, they have examples of how to do that. But there are other tools that you might look at We are partners with Sysdig, so obviously I would love you to look at them. But Aqua, other tools have runtime components. I don't know if Mirantis has anything, but that will actually monitor processes as they run. In the open source community, I will pitch Falco. Falco is a great tool, and if you're going to get your CKS, you need to learn a bit about Falco. It's a great tool for catching and alerting you to errant behavior, and it uses eBPF and other tools built into the kernel to find those things out. But scanning a container at runtime is it's more of a, what I look at that is it would be better to stop a container from being deployed that hasn't been scanned or hasn't been scanned cleanly. Does that make sense? See, Arnold asks, apart from KubeBench, what are other tools you could recommend to know one's Kubernetes clusters meet security compliance? Oh gosh, so there actually was one that was brought up on the. Let me back up. First thing I would do is start attending SIG security and tag security calls. The Kubernetes SIG security, CNCF tag security. We just talked about one of these in the SIG security office hours last week, and it is from. Oh gosh, my brain's gone. It's Kubeaudit, I believe is the name of it. There's several of these. So compliance is a loaded word. So compliance. I mean, honestly, for compliance things, I would look at KubeBench. That's the one that I think you use for the CKS, and it's a great tool. Sneaks tools will do IAC scanning of your deployment code. Again, we focus on the developer side of it, and we'll let you know if there's vulnerabilities coming in from any bad practice, I should say, coming in policy wise. But I wish I could remember who developed Kubeaudit. But anyway, there's several of them. If you start Googling around KubeBench, Kubeaudit, and I know there's like 3 of them right here in my brain. I can't think of it at the moment. You'll find them. But KubeBench is a great tool.
Yeah, I think there are like so many that we just have to like research and find the one that fits the organization needs. Yeah.
Honestly, I'm trying not to be a sneak, pitch person here, but all the vendors have something that we don't because we're not a runtime security company. But all the vendors who do runtime security probably have a tool, and often those tools are based on an open source version. So I'm a big open source proponent, so I would say take a look at the open source ones and see if they work for you. And if not, talk to the vendors. I mean, if you want to buy one.
Yep.
And again, we're partners with Sysdig as a full disclaimer, so they have a great tool.
Yep. Awesome. Thank you, Eric. Okay.
Open source.
So it's open source. It is. Awesome.
In fact, there's just to follow on to that. Sorry, the SIG Security has a tooling working group that I'm in. That's where that discussion happens. So that kind of stuff can be discussed there. Sorry, go ahead.
Awesome. Yep, that is helpful. I think if there are any other questions, just post it in there. If not, Eric, it's always like great to have you here, and then like always like love to connect with you and then like hear all your presentations. And this is very helpful for me, and then I'm sure like it's helpful for all our like listeners, and then like the people who will be listening to this talk in the YouTube channel as well, like go looking at the recording. So this is very helpful, and thank you so much for joining me here today. And with that, have like a good rest of your day, and then I'll connect with you later. Thank you so much. Yep, sure. Thank you everyone for joining me here today. We look forward to seeing you in our future Tech Talks. Thank you so much. Bye.